So we just want to remember our ultimate goal is to get the variable by itself. So we are trying to somehow end up with the variable x by itself. We are still using those inverse operations to solve. Now we just see a variable on both sides of the equal sign where we only had it on one side before. Okay, I want you to stop right there. Why don't you stop right there and have a seat? Because I think we have the right idea. So we know if these variables were on the same side of the equal sign, I could just combine them together. If I see 3x plus 2x equals 10, I know I can take 3x plus 2x, they're like terms. I can get 5x equals 10, and I can end up with x equals 2. This should look familiar. I'm just simplifying, combining like terms. Now, what we are going to see today is we are going to see problems where we have a variable on each side of the equal sign. So now I can't just add them together because they're split up by that equal sign. Now I have to think about those inverse operations to solve it and get those variables together. So, Graham, why did you subtract 3x from both sides? It's the same type of problem, so you have the right idea. Why do we subtract 3x? Okay, they're both x. I want to get them together. Alex, what do you think? I'm trying to move it to the other side. And what operation is being done in the problem with the 3x? It's addition. I'm adding 3x. The opposite of addition is subtraction. Now, we could have chosen to move the 3x to the left, which is what we did. We subtracted 3x from each side. Or I could have done it the other way and subtracted 2x. We should get the same answer either way. But let's do it the way that Graham did it. What is 3x minus 3x? 0. So this goes away. So what am I left with on the left side of my equation? Negative 5. Negative 5 plus 0 is negative 5. So I have negative 5 plus 0, that went away, equals 5. And then what'd you say, Joe? 5 plus negative 1x, or just minus x. I don't know, because they enjoy giving me a headache. Okay, so now we have, negative 5 equals 5 minus x. My goal is still to get that variable by itself. We're not there yet. What do I have to do next to try to get this variable by itself? Zach? Subtract 5 from both sides. Here, my 5 is positive. I want to move it to the other side. So I'm going to subtract 5 from each side. So I have negative 10 equals 0. 5 minus 5 is 0. Minus x. So what am I left with on the right side? Negative x. Because I have 0 minus x, which gives me negative x. Is the variable by itself? Is the variable by itself? It has that negative 1 in front of it. We have to remember this is like negative 1 times x. So what's the final thing that I need to do to both sides of this equation? Divide by negative 1. Remember, I always want to see that variable on the left side for your final answer. I don't care how you solve it. If you want to move it to the right, move it to the right. But make sure your final answer has the variable on the left side. Another way that we could have looked at this problem, I said earlier that we also could have gone the other way and moved the variables to the left side. So Alex told us that means I can subtract 2x from both sides. You don't necessarily have to write this down, but if you just want to see a second way to solve it, you can copy this down as well. So now I have negative 5 plus x equals 5. Now what do I do to solve this equation? Add 5 because it's negative here. Negative 5 plus 5 is 0. And x still equals 10. No matter which way we solved it, we got the same answer. Now, one way may involve more work than the other. You're probably not going to realize which way is going to involve more work until you get some more practice with the equations. But we can kind of see if I subtract 2x, that keeps my x positive, which makes it a little bit easier when I'm done. But you don't always have to do it that way. Just pick a side, move everything to one side. How can I check my answer? Substitution. So I can say negative 5 plus 3 times 10 should equal 5 plus 2 times 10. And we do get 25 equals 25. Our answer checks. It is correct. We have solved the equation. Are there questions about this problem? Remember, as soon as we have that equal sign, I can't just combine my terms together anymore. I have to use those inverse operations to solve. All right, so let's move on to these two equations. What do I need to do in my first equation? What's the first step that needs to take place in that equation? All right, so Joe helped him out a little bit.
I know exactly what to do here.
When we see those parentheses, we know we have to use our distributive property. So I'm going to multiply negative 2 times 3z minus negative 2 times 4. So now when I multiply this out, I get negative 6 minus negative 8. How can I simplify this side to make it look a little neater? Negative 6z minus negative 8. No. Because why? Two negatives make a positive. So I can make that negative 6z plus 8 equals 10 minus 6z. Now, I need to look. I have variables on both sides. How am I going to move it so that they're all on one side? What do I need to do to both sides of this equation? Can you raise your hand, please? Joe? Add 6z to both sides. What's negative 6z plus 6z? 0. 0 plus 8 is 8. Negative 6z plus 6z again is 0. Does 8 equal 10? What does this mean for my equation? What'd you say, Joe? If you looked in your book at example number 4, we should know if we do our work and we get to a false statement. 8 does not equal 10. That is not a true statement. That means that this is false, which means this equation has no solution. There is no value I could put into this equation that would make it true. As soon as we see a false statement, that means we have no solution for that equation. Make sure, I know you have already filled in your notes, make sure they are filled in correctly, that you are making corrections as you go. Yes? Let's look at the next example. So for the next example, we need to think about it the same way we did example number 4. So we're going to distribute negative 2 times 3z minus negative 2 times 4. Simplify negative 6z minus negative 8. Again, I can simplify this. Negative 6z plus 8 equals 8 minus 6z. All right, so let's again add 6z to both sides. So this does not look the same as this equation did. This equation, I had x equals 10. I had one solution. It told me exactly what my solution was. This gives me an equation 8 equals 8. What does that mean? Yes, but no at the same time. Everybody get your books open to this example. Obviously, you did not use your books as you were doing these. Section 4.2, example number 5. When I see a true statement.
Come on, I was just there.
Seth, what does it mean when I end up with a true statement? Well, look in your book next to example number 5 in section 4.2. Like I said 2 minutes ago, when I end up with a true statement, what does that mean? So we call this when we end up, okay, that's enough. You're being very distracting. When we end up with a true statement, we call that an identity. So now let's think about when we ended up with a false statement, we had no solution. So if I end up with a true statement, what does that mean about my solutions? Okay, how many? 1? 2 solutions? There's 2 numbers I could put in? What do we think? A false statement meant no solution. When I just got an answer, that meant 1 solution, x equals 10. Well, this looks different than both of those. So how many solutions does this problem have? Zach? And unlimited, and what number do we use for unlimited in math? So this has an infinite number of solutions. It does not matter what number I choose. I can choose any number that I want to. I can put it into this equation and it is going to be true. Whatever number I pick is going to work for this equation. Because I end up with a true statement, that's called an identity. There are an infinite number of solutions for this equation. So this slide kind of just sums up everything that we've said. There is no solution if we get a false statement. There's no value I can put into the equation to make it true. When I have an identity, any value of the variable will make the equation true. I have an infinite number of solutions for that equation. That's what an identity means. All right. Whatever we need to do first, do the first step. Mm-hmm. Okay, and what did you do there? By what?
Combining like.
So we combined like terms. Zach saw that we have this 4b and the negative 8b that we can combine together. And he got 12 equals negative 4b minus 4. Do I have a volunteer that would like to go do the next step?
Never have. Yep. Never.
All right, good. We have to undo that addition and subtraction first. All right, so the last step, we have to undo that multiplication by dividing on both sides. And we end up, and we can write, because we are talking about an equal sign, We can write our answer either way. Negative 4 equals b is the same as b equals negative 4. When we have inequalities, we really have to think about our order. When we have an equal sign, I can just switch the order. B equals negative 4 is the same as negative 4 equals b. Questions about that one? Does that help me get the variable by itself? We want to completely simplify before we start solving. Dante, what can I simplify in that equation? All right, so what is negative 1a plus 5a? All right. So we have to simplify by combining like terms. All right, that's first step. Seth, go on up and finish our problem for us. All right, so again, we combine like terms. We completely simplify first, and then we just have that one step. We have to undo that multiplication, one step of dividing, and we have solved our problem. And what did you do there?
Simplify.
By?
And
I don't see any combining like terms. We don't have like terms.
distributing.
So we used that distributive property, and we distributed 1/3 times 9b minus 1/3 times 36 equals negative 9. Yep. Finish it up for us. It doesn't matter. Whatever you would like. What do we think? We like it? Don't like it? I see Joe shaking his head no. Joe, why are you shaking your head no? We need to remember, what is negative 9 plus 12?
3.
It is 3. So we were very close. We had the right steps. And this is where it becomes extremely important to be showing our work. Because if you show me this work, I just take off partial credit instead of taking off the full points for the problem. So we have 3b equals 3. Graham decided we need to divide by 3, and what should my final answer be? 1. So if you show me that work, I can take off 1 point instead of taking off 5 points for the entire problem because all you show me is a wrong answer. Make sure you are showing your work. What are you doing each step? Write them down vertically, one step right underneath the other. So we can't combine like terms in that first step because we have those parentheses, and those parentheses mean I have to keep that quantity together. So to get rid of those parentheses, I have to distribute just the 2 because just the 2 is outside the parentheses. So I take 2 times x plus 2 times 4 and distribute that 2. Now that we have gotten rid of those parentheses, Seth, what did you do in your step? Okay, and what do we call that? Combining like terms. So we distribute, then we combine like terms. Who wants to go finish it up for us? Joe, go ahead. Good. So distribute first. When we simplify, we start at the top. So we have to get rid of those parentheses first. Then we combine like terms. Then I undo my addition and subtraction, and then undo my multiplication and division. All right, we've got 2 more problems here. Let's take a look at number 2. I want everybody to write down number 2. It's the one at the bottom. The one at the bottom that I am rewriting, that's the one you need to be copying down.
Red.
We've got this equation. I can see I have variables on both sides. I need to completely simplify everything that I can possibly simplify and then start solving the equation. What is going to be my first step in this problem? Zach? Distribute. There, he's got the word.
Got it down.
So I am only distributing what is outside the parentheses. I distribute the 4 to the t plus 5. So now I have negative 8t equals 4t plus 20, and that plus 2t stays on the end. So I distribute that 4 only to what is inside the parentheses. Now what do I do? Graham? I need to combine my like terms. They're on the same side of the equal sign. 4t plus 2t. So I'm going to get 6t, and then I have that plus 20 on the end. Now what do I need to do? And there are multiple answers. I think one is the best. Alex? So let's see, since we only have a variable on this left side, I only have a term with a variable in it, I would recommend moving all the variables to the left side of the equation. And to do that, this 6t is positive, so I need to subtract 6t from both sides. 6t minus 6t is 0. That goes away. I have negative 14t equals 0 plus 20. What's my last step? Alex? I need to divide both sides by negative 14. So now I have t equals, is my answer going to be positive or negative? Why?
Because you're behind by the
Okay, not just what am I? Okay, so the key here is that I'm dividing a positive by a negative. So I have one positive, one negative, so my answer is going to be negative. Can I simplify that fraction? How can I simplify it? Okay, each of them have a factor of 2, so I can divide the top by 2 and the bottom by 2, and I can get negative 10 over 7. I could also write this as negative 1 and 3/7. 7 goes into 10 one time, and then there's 3 left over. Questions about this problem? Remember to completely simplify, and then when you are done simplifying, start solving your equation. All right. Here is your homework.